So for the day 12 notes, we're going to continue to talk about double angle identities, and we're going to talk about how to use double angle identities to solve equations. So if you look at example 1, we're asked to solve on a specific interval, so we're going to be looking for x values or angle values between 0 and 2 pi, much like we were solving equations earlier in this chapter. But we're going to be using double angle identities to first simplify the equation before we can solve. So just to refresh on our double angle identities, the double angle identity for sine of 2x is 2 sine of x cosine of x. And then for cosine of 2x, or cosine of 2 theta, or 2u, or cosine of 2 times any angle variable, there are 3 different ones. So one of them is 2 cosine squared of x minus 1, or 1 minus 2 sine squared of x, or cosine squared of x minus sine squared of x. All 3 of those would work. All 3 of them are equal to cosine of 2x, but depending on what the equation is, we'll hopefully determine, or hopefully we'll be able to determine which of the 3 double angle identities for cosine we would use. And then the double angle identity for tangent of 2x is 2 tangent of x over 1 minus tangent squared of x. So that's just a refresh. Those are on the identity sheet we were given last class, but wanted to put them at the top of the notes here because we're going to be using some of them. So back to example 1, we're looking at the equation sine of 2x equals 2 sine of x. And just to be clear here, that 2x on the left side is inside the parentheses. There's nothing we can do to take that 2 out. Dividing both sides by 2 would be a strategy that really isn't allowed because that 2, like I said, on the left side is inside the sine function. So what we would do is actually use one of our double angle identities. So if we use the double angle identity for sine of 2x on the left side and call it 2 sine of x cosine of x, now we have an equation that no longer has a double angle. That's the advantage to knowing or using these identities. And what I can do here is solve this equation like we did earlier in chapter 9. So what I would do is move everything over to one side. So subtract 2 sine of x from both sides. And I would get 2 sine of x cosine of x minus 2 sine of x equals 0. And then to solve this equation, I would factor out a 2 sine of x from each term on the left, which would give me 2 sine of x times the quantity cosine of x minus 1. And now that I have 2 terms being multiplied together, that's equal to 0, I can set each of the terms, or each of these products equal to 0. So I would set 2 sine of x equal to 0 and cosine of x minus 1 equal to 0. And then for solving these, it's going to be just like we solved them earlier in the chapter. We're going to get the trig function by itself, and then ideally we'd be able to identify the angles without drawing or looking at a unit circle, because if we're asked to do this without a calculator, which we will be for this type of problem, these should work out to be angles that we know. So again, I'm going to divide both sides by 2 on the left here, so I get sine of x equals 0, and the 2 angles, or x values, where sine is 0 are 0 and pi. And those come directly from the unit circle, and they are exact angles because we had an exact value for sine. And then for the other term, cosine of x minus 1, add 1 to both sides. So I'd get cosine of x equals 1, and the x value is 0. Now there are many more values that work, but because we're restricting our answers between 0 and 2 pi, and 0 was actually already a solution in the other term, I don't have to write x equals 0 again. I just kind of leave x equals 0 and pi circled. But if you put a circle or a box around x equals 0 again, it's not wrong. It's just a repeated solution, so you don't have to write it twice. So the 2 solutions to this equation are 0 and pi, and in order to solve this one, we used our double angle identity for sine to simplify the equation. And for example 2, we are going to again solve an equation on the interval 0 to 2 pi, and we're looking at cosine of 2x equals negative cosine of x. So what I would do is use one of my double angle identities for cosine of 2x, and this is what I mentioned before, is which one you use is kind of dependent on the the question. So I look at the right side of this equation and see that it's just a cosine. So it might be a good idea to use the trig identity, the double angle identity that has just cosine in it. So what I would use here is 2 cosine squared of x minus 1 equals negative cosine of x. And the hope is by using just the double angle for cosine that is 2 cosine squared of x minus 1, I'd maybe have something that can be factored or something that can simplify, and I would just be dealing with cosines here rather than using one of the identities that uses cosine and sine, or 1 minus 2 sine squared. So again, you might not find the perfect solution right away. You might try one of the other ones and kind of come to a point where you see there's nothing you can do, and then maybe go back and try one of the other double angles. But again, I saw that the right side was only cosine, so I used the double angle that was just cosine in hopes that this would be something that maybe factors or simplifies a little bit further. In order to see what happens here, I would move everything over to one side. So I'd add cosine of x, so I'd get 2 cosine squared of x plus cosine of x minus 1 equals 0. And that is something that can be factored, actually. So it's going to factor into 2 binomials. And then the first term of each binomial is going to be 2 cosine of x and cosine of x. And then I need to find factors of negative 1 that would make my outside-inside product add to cosine of x. So I'm going to show my check here just to make sure that my plus 1 and minus 1 are in the correct place. I highly recommend, especially when you're factoring the trig functions, to at least mentally check that your signs are in the right place. Otherwise, if I had plus 1 and minus 1 in the wrong spot or in the wrong factor, then I would get completely different angles and therefore probably miss some solutions here. So to check, since I wrote the first term of my factor, 2 cosine of x and cosine of x, I know that when I multiply those I get 2 cosine squared. And because my last terms of each factor are plus 1, minus 1, I know when I multiply those I would get minus 1, which is my last term. It's really the middle term that has to be created in the correct order. So again, I'm going to check my outside-inside product. So my outside product, 2 cosine x times plus 1, gives me plus 2 cosine x. And then my inside product would be negative 1 times cosine of x, which would give me negative cosine of x. And if I add those together, I get positive cosine of x. And you don't have to write this check out. I just wanted to show you kind of how I'm making sure that my factors are correct before I go ahead and solve. Because again, if I had my 1 plus 1 minus 1 in the opposite spots, my outside-inside product would have given me negative cosine of x, which isn't what I needed from the previous step, which means the angles I found further on in the problem definitely wouldn't be the correct angles, and therefore I would miss some solutions when I could have just taken a quick second to check my algebra here. So again, I'm going to erase that's not part of the problem. It's just checking to make sure my factors were correct. Now I'm going to set each of these binomials equal to 0 and then solve them. So the one on the left here, I would add 1 to both sides and then divide by 2. So I'm just going to go straight to cosine of x equals a half. And the binomial on the right I set equal to 0. I'm going to subtract 1 from both sides. So what I'll get is cosine of x equals negative 1. And then cosine is a half and cosine is negative 1. There are specific angles on the unit circle that we should definitely know, or at least start to get really comfortable finding those right away. If you need to, draw a unit circle, draw quadrant 1 as a reference, obviously go ahead. But the hope is, as this chapter continues, we'll get more and more comfortable being able to identify these values. So cosine of x is a half. When x is pi over 3 and 5 pi over 3, that would be an angle in quadrant 1 and quadrant 4, because that's where cosine is positive. And then cosine of x is negative 1 at pi. So this equation, 2 cosine of 2x, has 3 solutions, and I used one of my double angle identities for cosine to first simplify so that I could solve this equation much like we did in the first section of chapter 9. So that's the notes for today. The homework will be similar problems, being able to use our double angle identities, and then proceed solving trig equations.